Hello, welcome to the Machine Learning at Home. Today I will speak about neural gas. Very strange name, but this is a name which related with artificial neural networks. So this is kind of networks which are not really very similar to what we call neural networks today, because they were made in a kind of artificial way. So they are not self-growing or something else. So these networks, however, are quite useful for machine learning because they have very good predictable results. So one of neural network system is neural gas. Bit complicated ideology, but it works like it works typically for most of clustering systems. So I will show today how to use neural gas in the first way. Actually, in R, you can run neural gas in two different packages. So first of all, this is a package cclust. So library cclust. Again, if you do not have this library installed, then you will receive error, and you must install it with the command install.packages, not the plural, and cclust must be in quotes. And then you run library cclust. And then you go with cclust command. Cclust command will accept several arguments. First of all, we need a data set. So for some reason, cclust will only accept matrices, not data frame. So we should use iris without fifth column as usual. But we need to convert it into matrix with as matrix. And that everything should be fine. You must also provide the number of clusters. In that case, centers is a keyword, equal to 3 because we have 3 species in that data. And also because cclust will implement several clustering methods, we should provide method neural gas. So this is an artificial neural network which however makes the clustering quite efficiently. So and then of course we should write it down to some new object. For example, iris.ng from neural gas. Yeah, do you see which is an error? Now I can see it easily because we should specify not the column number 5, but data without column number 5, -5. Now everything went well. And, well, what to do with iris.ng? One of possible ways is to use my misclass confusion matrix. So library Shipunov, and then we should provide some arrangement for new data clustering and old data clustering as arguments for command misclass. So new data clustering first. So our object is called iris.ng, and within that object there is a cluster part. And then we use iris species as actual initial clustering, true one. And then we must also provide option best equal to true. Without that option, things will not work, as they will not never work in any other package except mine, which is using like very straightforward approach to confusion matrix. So my package find the best combination of new cluster, the numbers, and species names. So as you see here, misclassification is very low, about 11%. Well, slightly bigger than many other methods, slightly lower than other methods, so kind of in between, and good results. So that artificial network, despite the name, works quite well as a clustering tools. And also we can look closer where exactly are mistakes in how they are distributed. So for example, we can plot the result and see what is going on. So plot, for example, to plot we need somehow arrange our data in two-dimensional structure. So one of the best ways is a principal component analysis, PRComp, and then we need again provide a data name, which is iris without fifth column, without, shouldn't make this mistake again, and then we need a X component of that PRComp object, and then we will colorize by species, original species, iris species, and we make a shape of dots in accordance with new clustering, PCH equal to iris.ng cluster. Okay, sounds like everything is good enough, right? Let us see what's going on. Yep, so you can now see the plot, and in that plot you can see the block and triangles are perfectly correct, because in Setosa all specimens are classified properly, whereas in two other species they're not classified properly, as usual I would say, and some pluses are red, most of them, but some of them are green, and also there are few red circles. So as you see here, versicolor, this green species, is classified better than Virginica, the first one, which is red in that plot. So as you see, this is a reliable method, and now you can use neural gas for clustering application. It has its own problems, but works without any on the iris data. So again, neural gas in the first way. And next time I will try to explain the second way of making neural gas artificial networks. Thank you very much.